since this is our first lab, the determination of water content, I want to introduce a couple things about this lab, because throughout the rest of the soils laboratory course, we are going to be using this procedure for water content, because 3 out of 4 of the remaining labs will have us do a water content as a component of the test that we'll be producing. So we have 5 total labs. This one is determination of water content. The second one is a sieve analysis. That won't require us to do a water content test. But lab 3 is a liquid limit test, and lab 4 is plastic limit test, and lab 5 is a proctor compaction. And all of those labs require this procedure to be included in it. So you should be aware that anything that is related to this lab, that is, for example, a source of error, and how to do the actual procedure for measuring the lab, conducting the lab, that is this part of it, is also applicable to labs 3, 4, and 5. Okay, so I'm going to first introduce the minimum necessary components, the equipment. And so when I talk about what is required for this part of the test, those things will also be required to conduct that part of the labs 3, 4, and 5. Okay? So you will always need a marking pen. That marking pen will be used to record your data, and in that you will have a data sheet that will always be provided to you for printing in the effort to record your data in each lab. And you should always assume that you're going to need something to mark your moisture cans with. These are moisture cans. I'll show you up close. They have a lid that normally stays on the bottom, but on parts of the other labs we will put them on top for a temporary condition. The can lids can have a tendency to stick, but we are going to try and use the newer cans. They get reused a lot of times. But in our case, I'm going to have a pre-labeled set of cans. And so you're not going to see me use this permanent marker, but you should have in your list of equipment something to mark the moisture can. So I've got a permanent marker here. Okay? You will need 3 sets of moisture cans for this lab, and that is because to get this particular piece of information, you're going to need to average the results of 3 different data points. Your future lab tests, they're going to have a minimum of 3 data points, with the exception of your plastic limit test, and that will only have 2. So that's the only exception to this. Now, you will need something to transport this soil that you're going to put from the receptacle it's in, whatever it is. In mine, it just happens to be a random plastic container. And you're going to put that tool, you're going to use that tool to transfer the soil into the moisture cans. So I've got a garden trowel. In other labs, it might be some other piece of equipment or tool, or you may be using your hands, depending on what the lab is. And you will need a scale. In this particular scale and this lab, your scale has to have a precision of 0.01 grams, and that will be the case for all of your moisture content measurements throughout the rest of your labs. 0.1 grams. And over here we have our oven. I'm going to adjust the angle here so you can see it fully. Now, this 7-volt oven, and you can't see the dial over here, but the oven is established so that in Celsius, you must have it's set to 110 degrees plus or minus 5 degrees Celsius. But our oven measures in Fahrenheit. So in Fahrenheit, that is 230 degrees Fahrenheit plus or minus 40 degrees Fahrenheit, roughly, when you translate that into Fahrenheit. Now our moisture cans, the size of the moisture cans we'll be using throughout the labs is a 2 3/4 inch diameter by 1 3/4 inch tall. And so you'll get to see that. Let's see. So 2 3/4 diameter by 1 3/4 inch tall. Now, you will have already become familiar with my method of doing attendance. So your attendance question for this particular lab day is, how many years of experience do you have in the construction industry? Now, some of you taking this course are going into civil engineering, and some of you are going into construction management, and some of you are going into related fields like interior design. So if you have any experience in those related fields, that's what you answer the question. So at this point, you pause the video, go answer the attendance question, and come back. And that's all it is. Moving on. So, to conduct this lab, first thing we need to do is fill out the header for this lab. I'm going to show you this. Very first thing, what is the date, the description of the soil, and what is the sample number. Now, for our purposes in this class, you're going to get to make up the sample number. I've already discussed by this point that you are creating a fictional client and a fictional project, and therefore you get to create a fictional sample number. But you're going to get this opportunity to do a location that you supposedly took this sample from. So you get to do a little bit of creativity in the process. So today's date, for my purposes, is April 11th, 2019. Now the soil description I'm going to show you the soil. This is light brown silty soil is what I have decided to call this description. So I'm going to write that down. And I'm going to call this sample 2 because 24 hours ago I did sample 1, and you're going to see me pull those samples out of the oven so we can see start to finish what the process of doing this lab is. And our location, for my purposes, I'm going to call this Bloomington, Indiana, because that's actually where this soil came from. Now, your fictional location can be filled in there. This is, let's say your fictional location was a roller coaster in the middle of Disneyland. We'll put Disneyland as your location. That is fine. But be consistent, because that location will get used on all the rest of your labs. Okay? Tested by will be your name. So in my case, I'm going to put my name. All right. So this is my header. Boop. There we go. Now, the next thing I'm going to do is I'm going to fill in the can numbers. This can number is what I've labeled the cans with already. And then I'm going to weigh each can. That's this second empty space line here. The cans empty are going to be weighed on the scale here. So my first test number 1, I'm going to say is 4H, test 2 is 5H, and test 3 is 6H. Okay, so in order to make a measurement, you always zero the scale. If you zero the scale, then you know that there isn't any residual miscalibration in the measurement. So I put my first one on there. It says 3846. And I write that down. And I repeat that process for the other two. I don't think it zeroed it correctly. Okay, now the next part, because this is just testing the moisture content, I want to take the wet soil and put some sample in each one of these. Now this doesn't look wet, but there is a little bit of moisture in this. And in some cases you will see moisture because the sample you pull from the field will look more wet. But we're going to dry it for 24 hours to see exactly how much moisture is in it. So I'm going to put a sample amount in each cup now, or each moisture can. I am filling it about half full because I want about a significant amount in here to do this test. And so it's about half full. So I'll do that 3 times. Okay, one more thing that I forgot to mention that you will need in your equipment list. You'll need gloves because you can't pull samples out of the oven without them. So something to handle the hot cans for when you remove them from the oven. So, well, I'm thinking about it. Anyway, so now I zero the scale again for the first one. And I make sure when I record it, I put it under the right can number, because one way to get the data wrong is to record the weight in the wrong column. Now, that is not a source of error. Let me be clear. If it is a correctable human error that can be corrected by just redoing a portion of it, then it is a human error that you can fix. If it is a source of error that you cannot avoid, then it is an acceptable source of error for your report. And after I complete this part, I will make sure and discuss that from among the sources of error that I have. Now, for this part, this is what my page looks like. Okay. Now, like I said, I did this 24 hours ago, so I have a different sheet. It's all filled out, waiting for me to pull samples out of the oven. So, just as soon as I am done weighing these samples, they need to go in the oven. So since they are cold, I can just take them, put them directly in the oven. But I need these to take samples out of the oven. Okay, so while that cools a little bit, I'm going to discuss sources of error. All right, so the process of taking a sample from the field usually involves, let me put this back in this direction. Okay, so the process of removing a sample from the field usually involves coring all the way down deep into the earth and then pulling a sample out. So it's usually not a surface sample. So usually it's not going to be impacted by rain and hot sun unless the sample has been exposed once it has been pulled out from this coring process. So we've got these boreholes and they pull out the sample and they take the sample from the site to the lab. Now, if it has been delayed a very long time between that sample site and taking it to the lab to be tested, and it happens to be a really hot day or a really humid day, that can change the moisture content. But that is a pretty rare thing. Here in Terre Haute, we do get things like trains delaying things. So if you happen to have a train that delays you 40 minutes and you're sitting on the tracks, or waiting behind the tracks for a train to pass, that is a reasonable source of error. It's if you are sitting there and your samples are drying out, that's a potential error that you couldn't avoid. That is a rare thing to have happen, and if it's a significant impact, or in the judgment of the geotechnical engineers, a significant impact, they might take additional steps like redirect their path to try and avoid that particular blockage, or if it really, really is critical and they think that might change the test values, they may ask for additional tests. It is expensive to do that, so it is something that they try and do a lot. They avoid it at great cost. Okay. That said, there are other ways that, or other conditions that can impact the reliability of water content tests. The environment of the lab is one source of error. Now, when we conducted this lab earlier in the semester, it was conducted during the really, really cold spell that came through here in the Midwest. And the first face-to-face lab that did this was, they came in on the Tuesday right before ISU closed campus because the cold was so frigid that all of campus shut down. And the second one came in the next day to do their lab. So I actually had to do the second measurement for the Tuesday lab group. Now, that's not in and of itself a source of error that I had to do the second measurement. The source of error is the fact that if you're able to look around this lab, and I'm going to show this other camera that, this lab is a very, very big room. All right. Now, if you imagine this very, very big room also has a very tall ceiling, you can imagine it also didn't keep heat very well. In order to maintain heat, I actually had to bring in some space heaters just to make it tolerable, and I had the students come in wearing their coats because it was still not tolerable with space heaters. And because of that is the environment of the lab, and when the air is that cold, it also has a tendency to dry things. That is also impacting your samples. So if your samples are being exposed to an excessive amount of humidity or dryness because of the conditions you can't control, that does introduce a source of error. Other sources of error, if there is a source of error, must involve something you cannot control. A factor in the process you cannot control. For example, if the power goes out, and that means the oven didn't stay on for those 24 hours. Now what happens if that happens? Well, then you redo the test. Unfortunately, that can happen. So when a test fails because of something outside of your control, the only realistic thing to do is to redo the test, because if it is such a large source of error that the test results are meaningless, unfortunately that means redoing the test. So that is a possibility. Now, any source of error that is avoidable or is completely correctable because it's human error and we can fix those things is not a good source of error. For example, bad math. You can correct bad math. Also, in your lab groups, if you and other students are recording the data and one student records it differently than another, then it's good to check with each other. Hey, did you record this as a 2 or a 7? Because that does make differences. Another source of error that is correctable, if you happen to put a thumb on the scale while taking the measurement, that is definitely just sloppy measurements. That is not a good source of error. That's just taking a sloppy approach to your process. So when you're writing your reports, the key question you should ask yourself, is the source of error avoidable, correctable, and can I double check it with someone else in my lab group? Now I realize all of you are distant students, so that's hard to double check with other people in your lab group because you are not in lab groups, you're working in a silo. But I have given you discussion boards to talk to each other about good sources of error, and you have something called Google that will also give you lots of great ideas. I encourage you to use it to help enhance your critical thinking of this. I am not asking you to get all of your information from Google. What I want you to do is use Google as a source to try and bring in good ideas. Put it on the discussion board. I will respond to it. What I want you to do is use the discussion board for each lab, post what you think is a source of error, and then I will respond to it. Now, the way I'd like you to do these discussion boards is write a thread for each source of error that you think is applicable. In other words, title the source of error as the thread title, so that other people can find what they think is the source of error and add their thoughts. And I will make sure that I respond to each and every thread so that everyone can get an idea of what are good and bad sources of error. Okay? Now, that said, if you do not post to the discussion board, you don't get access to all those good answers. Okay? And this is an important part of the critical learning, critical thinking process that will help you enhance the results of the quality of your report. All right, now that this has had a chance to cool off enough to touch, we are going to remeasure these. All right, so I zero out the scale and remeasure the weight. Now this new measurement goes in the line that is titled mass of can plus dry soil. Now make sure again that you are recording your weight in the column that corresponds to the correct can number. I've got 1H, 2H, 3H, and just for quality's sake, I always measure them left to right in the same order as I have them in the table. So I never make the mistake of putting them in the wrong column. That has happened, and then the correction has been that other students in the lab group have helped each other fix that problem by comparing notes. Okay? So once that is done, the calculations are automatically done in your spreadsheet. Now, I provide you a spreadsheet for each lab. Now, it does not relieve you from needing to know how the math is done. And in your report, you still have to demonstrate for me that you understand the math. But the math is provided for you, in most cases, as an equation on the left side. So you will do a representative data point for the math that is in the green boxes, and in some cases the blue box. So here's what happens. In this case, you're going to take the M2, let's see here, M2 minus M3. So you're going to take M2 minus M3, and that will be this first number. And in the second case, you're going to take M3 minus M1, M3 minus M1, and put it in this box. And like I said, my spreadsheet will do that automatically, so you can verify that your hand calculation matches the spreadsheet. And then in this last case, you're going to divide you're going to take this number and divide by this number, and then multiply by 100, because it will be a fraction less than 1. So it becomes a percent, okay? And you will end up with, on the last three boxes, you're going to end up with a percent. Well, then that gets averaged right here. So if you don't know how to take an average, I suggest you Google it. The average of these three numbers becomes the number that shows up in this blue box. And that is how you do a moisture content calculation, okay? Any more questions, you can send me a message, email me, or post a question on the discussion board. All right, thank you.